Okay, this is the notes for section 3.4, which is graphing linear equations in standard form, which I wrote up here. So first off, let's write a couple equations down here. This is what's called slope-intercept form, which we've already done. Okay, we've talked about y equals mx plus b already. Now here's the new form that we're going to discuss, and this is called standard form. Now, a couple things about standard form. You may notice there's no m or b. Okay, there's a big B, but that means something different. It's not a little b, because little m and little b represent slope and y-intercept. This just basically means that all the x's and y's are on one side, and your c is your constant. A and b just represent coefficients. That just means that they're numbers in front of your x and your y. Okay, an example of standard form would be something like this. It has x's and y's on the same side. They are coefficients. They have whole numbers, and there's a whole number on this side. Okay, now let's talk about some basic graphing things that we're going to be going over. Okay, horizontal lines. So if I said I wanted you to graph the line y equals 4, that's the same thing as y equals 0x plus 4 because it doesn't have any x values in it. So how would we graph that? When you go to graph your line, you go to where y is 4, which is up here, and then every y point, no matter what x is, will always be 4, no matter what, no matter where it is, which is going to create a horizontal line. So horizontal lines are in the form y equals. So this one said y equals 4, it's 4 units up. If I said I wanted to graph y equals -2, it would just be 2 units down, and it would also be horizontal. Okay, so all horizontal lines are in the y equals format. Okay, all horizontal lines are y equals lines. Vertical lines. Vertical means up and down. Horizontal means left and right. Okay, so to get vertical lines, let's say I wanted us to graph x equals 2. What I would do on my graph, I would find where x is 2, which is right here. Okay, x is 2. And no matter what I put for the y value, x is always going to be 2, which makes a straight vertical line. Okay, so now some key things that we need to remember for these. Horizontal lines are always y equals lines. Vertical lines are x equals lines. Now let's talk about the slope a little bit. If I put a person on the left-hand side of the line, and we chatted about this the other day, the slope is 0. Okay, reason why? This is like walking on cement, okay, or the carpet. It's completely flat. Notice that the value in front of x is 0 because it didn't have one. This one actually has an x value. It has x equals 2, but there is no y value. So think if I tried to put a person on the left-hand side of this line, what would happen? They would fall, and they wouldn't make it. This is called no slope or undefined slope. Okay, so what that means is when you start looking at the pictures, all x equals graphs are vertical lines, and you cannot walk on them. That you cannot write a y equals mx plus b equation for this because it's just x equals 2. And your y values are always going, if there's just a y and there's no slopes, those are going to be 0 slopes, and they're going to be completely flat horizontally. Okay, now let's talk about pictures of graphs where we have an x-intercept and a y-intercept. So let's say I gave you a picture that was actually not horizontal or not vertical. Let's just say it looks something like this. And I put little dots here. Well, the y-intercept's pretty easy to figure out because we've already done that. It's the b value, okay, if it has one. But it's basically where the x crosses, or excuse me, where the line crosses the y-axis. Okay, where graph crosses the x-axis, or excuse me, y-axis. My bad. So then your equation for this will be 0, comma something. The x value is always 0. And then wherever it crosses, let's just say it crossed at 2. Now let's do the same thing for this one. Let's say it crossed at 3. This guy is going to be the x-intercept, where the graph crosses the x-axis, which is 3, comma 0. Okay, so they look kind of like this. Okay, so all we're basically doing here is we're talking about what the pictures look like of how to find the x and y intercepts. And they're basically going to be pretty simple if you just look at the pictures. Now, sometimes they don't have an x and y intercept. For instance, let's go back up to the problems that we had up here. Let's say we had this line here. This one definitely has a y-intercept of 4. 1, 2, 3, 4. But it doesn't ever cross the x line. No x-intercept, int. Now, if we go to this one's going to have an x-intercept of 2. It crossed at 2. But it has no y-intercept because it never crosses that. It's parallel to that line. Okay, so now these are just some brief introductions: horizontal line, vertical lines, how to find x and y intercepts by just looking at the pictures. Okay, so now let's take this to find the intercepts to graph the equations. Okay, so now remember the problem that I gave you guys way up here. We're going to talk about how to solve that. So this is going to be example 1. Use intercepts to graph the equations. And we're going to do 5x plus 3y equals 15. Okay, now this is actually really, really helpful. There's a trick to this that will make this much, much easier. Okay, so now let me just show you what we do for the trick. What if I covered up the first value, and that's all I had? What would make this true? So when I cover it up, it's kind of like saying x is 0. If I made x 0, 5 times nothing is nothing, so I'm just going to cover it up. That made a 0. Well, 3 times what makes 15? Wouldn't that be 5? Well, that is the y-intercept. We are going to do the same thing with the other value. Now, this is a little harder. I got to see if I can come up with a little thing to cover this up. Okay, so now let's say I do this guy. Let's cover up the y, and let's make the y 0. So if I cover this up, what's going to make this true? 5 times 3 would make 15. And that's going to be the x-intercept. Okay, so now we're going to graph this based off the pictures that we had. So if I do a little quick graph, I found the y-intercept to be 5, 0, 5. Put a dot there. And my x-intercept is going to be at 3, 0, which is here. Connect these and draw a line. And this is going to be the graph of my equation. So I use the intercepts. I got my points. My 0, 5 is my y-intercept, which is here. And my x-intercept is 3, 0, which is here. So this is going to be the graph at the points that we have there to get the equation. Okay, so let's try one that looks like this. Same idea, different numbers. Let's cover these things up. I'm going to start off with this one. If I cover this up, I would get a y-intercept of 2 times 3 makes 6. And you can write that as 0, 3 because x is 0. Now let's do the x-intercept by covering it up. I'm going to go to this one, cover this up. Wouldn't that just make x equals 6? And that's at 6, 0. Here's how we draw the point. 3 up, put a dot there. X-intercept 3, 4, 5, 6. There's our next one. Now, this will work always in standard form. You can cover things up, and it will tell you the answers, the locations of where these graphs cross. Okay, now I'm going to do a couple of these because I want to make sure that we're getting this. These are all the same directions. Okay, so let's say we have 2x minus y equals 4. If I'm moving a little fast, pause this, rewind it, look at it again. Okay, remember what we did on these other ones. To start off with, we're going to cover things up. So I'm going to start off by covering this up. I get 2x equals 4. So that means my x-intercept, 2 times 2, makes 4. So that's going to give us the point 2, 0. Okay, now let's cover this guy up. The opposite of something equals 4. Well, the opposite of -4 would make 4. And there's your point. So now let's take these and let's graph them. 2, 0, 0, -4. Whoops. And that's what our picture would look like. Now, these are pretty simple when you start going through them if you know the trick. So remember the trick. Cover these things up as you start going through. That's how you can find the x and y intercept. Now, notice every single problem has been in standard form. X and y on the same side, constants on the other. X and y on one side, constant on the other. X and y on one side, constant on the other. Okay, now let's do, I have a word problem. This is our last one. It says you, oops, let me move this down a little bit. You are going to the fair. Okay, this is obviously pre-COVID. And have $16 to spend on rides and games. Okay, that's all the money we got. 16 bucks. That's not too much. Rides cost $4 each. And games cost $2 each. Now, this is assuming we don't have one of those special little bracelets where you can go do whatever rides you want. So we're going in there with just money. And no bracelets, nothing like that. The equation 4x plus 2y equals 16 models the situation. Okay, and we're going to talk about that once I'm done writing all these things down, how we came up with those numbers. Okay, x equals number of rides, y equals number of games. So part A, graph this thing. B, find 4 possible solutions that would work. Okay, so now before we get started, let's take a look at how they came up with this equation. It costs $4 to ride, so we're calling X rides. $4 each ride. $4 a ride. Games cost $2 a ride. $2 a ride. Y value. And the grand total of how much money we have is 16 bucks. So to graph this, we need to try to do this, just like we did on these other problems. So we're going to cover things up. Okay, I'm going to start off with this one first. 4 times something makes 16. Well, that something would have to be 4. 4 times 4 makes 16. So the first point would be 4, 0. Go to my next one, cover it up. This is my y-intercept. Now, how do I know it's the y? It's the letter that's left. 2 times something makes 16. That something has to be an 8. X is 0, y is 8. Now, if it says y-intercept, notice it has the number. The other one is 0. X-intercept, we got a number. The other one is always 0. Anytime you find an intercept, the other value will always be a 0. So now it's telling us for part A to graph these points. So I'm going to do that. 4, 0, and 1, 2, 3, 4, 5, 6, 7, and 8. And here's what our line would look like, or we would assume that it would look like. Now let's talk about ideas for possible solutions. X's and Y's. X has to be how many number of rides we get. And the Y value is number of games that we get. Now check this out. Is it possible to get negative values? Could I get Y values that are negative? Would it make sense to buy negative games? Okay, you can't spend negative money, so the graph doesn't go that far down, and it doesn't go this far down. So we have to come up with some different answers that could possibly work. Well, here's one of them. Or excuse me, here's two of them. It says, find 4 possible solutions. Here's 1, here's 2. We could have spent all our money on rides. That's what 4-0 means. It means we got 4 rides. 4 times 4 makes 16. We didn't want to do any games. We just did all rides. Okay, so now let's see what else we could have done. We could have done 0-8. That means we did 8 games. 2 times 8 is 16. We didn't do anything else. We did 0 rides and 8 games. Now let's see some other things that we could have possibly done to spend the $16. What if I picked, it looks like 3-2 is a possibility. And let's see what that means, because any point along here could possibly be an answer. But here's the deal. You can't get fractions, because how could you ride a half of a ride or do 2.5 games? They have to be whole numbers. So this one's telling me I did 3 rides in 2 games. So this is 3 times 4, which makes 12, and 2 games, which was 2 times 2, which is $4. And if I add those together, they make 16. So that's another answer that's possible. Now you might have to guess and check to try to find some of these things that work. Here's another one that works, which is 2-4. 2 rides, that's what this represents, in 4 games. Okay, 2 rides times $4 makes $8. And 4 games times 2 makes another $8, which is a grand total of 16. So they all made we spent all our money's gone, and these are all the different possibilities you can have. Now you could start guessing some. Now just to show you, here's one that doesn't work, but you could try. What if we did 1, 5? See if that works. I mean, I don't know. Let's see. Let's say if we did 1 ride and 5 games. Okay, that'd be 1 times 4, which is 4, and 5 times 2 is 10. That would only add up to make $14. So what if I did 6 games instead? 6 times 2 is 12. That would add up to make 16. I could have done that if I decided to do 1 ride and 6 games. So there's a lot of different possibilities that can work. And if you look at the picture, 3, 4, 5, 6, it looks like it's probably about right there. And so there are more possibilities than just 4. Okay, this should get you guys through the notes from Monday, Tuesday, and Thursday, Friday.